Question number 1. Choose the most appropriate response from the given options. What was your answer? The question is, there are two heaters. One is of 1000 watt, other one is of 1500 watt. Which heater will have more resistance? B will have more resistance. Okay. Why did you say so?
Because the power is more.
Power is more. Okay, let me ask you, what is the relation between power and the resistance? Well, you have learned so many formula. Now, one of the formula gives the relation between power and power is directly proportional to resistance. So, you think about that in your household circuit, you have learned something like this. Power is equal to VI. Another formula, power is equal to V squared by R. Another formula. Okay. Another formula. Power is equal to I squared R. These are the formula which you have learned, no? Power is equal to basically work by time, that is there. Okay. So in this formula, which formula will help you to answer this question? The question, let me repeat. Power rating of two room heaters A and B working normally. The room heaters are working normally. That means they are getting the required voltage. What is the required voltage for a normal working of an electrical appliance? 220 volt. Okay. That means both are getting same voltage. Voltage is the same. Which formula will help us? This formula, no? So voltage is same. Okay. When voltage is same, this, look at this. Power is inversely proportional to
resistance.
Power is inversely proportional to resistance. So power is inversely proportional to resistance. What does it mean? If resistance is less, power will be more. Provided this V is constant. Okay. So resistance is less, power is more. So power is more, resistance will be less. So which is having more power? More power is for a B. So its resistance will be less. You can think another way also.
Sir, once again, can you repeat the question?
My question is, two heaters are there, A and B. Which heater needs more current for its normal working? Both the heaters are not taking same current. Which heater needs more current? B must need more current. Why? Its power is more, no? So it needs more current. Please understand, a 20 watt bulb needs less current only. 30 watt bulb needs more current than that. So power increases, current also increases. So which heater needs more current? B needs more current. Okay, so its resistance will be less. Oh, if resistance is less,
Then
current will be more current now, right? So that way also you can think. Okay, first answer is option 4. Resistance of the heater A is greater than that of B. Second one, a diagram. I think that you understood. As per the diagram, current is flowing upward or downward. Here wire is there, and here one battery is on.
Oh, yes, downward.
Okay, battery here. This is positive terminal, right?
Yeah,
So this is the wire which we are talking about.
That wire we are talking about.
Okay. So current flows in downward direction. Okay.
Yes.
Well, now around this magnetic field will be there. So if you are looking from the top, if your view is from the top, can you tell me what will be the direction of magnetic field here? Clockwise or anti-clockwise? Which rule will help you?
thumb rule.
Right hand thumb rule. Okay.
Like this.
Okay. How is that? You will keep your right hand
Like
such a
this.
way that the thumb shows the direction of a current.
Direction of
Then other fingers will encircle the wire in the direction of magnetic field. That is what you have learned. So what will be the clockwise or anti-clockwise?
Clockwise.
From the top it will be like this, no?
Clockwise.
If you clockwise, no? Right? That's okay. Then which compass is correct?
C.
Yes. Compass C is correct. Compass C is on the other side of the wire.
Yes, sir.
So compass C is correct. Okay. Next, what does thumb indicate in Fleming's left hand rule?
Direction of force on conductor.
Direction of force on conductor. Can you tell that rule? Fleming's left hand rule? Yes, please. Stretch your forefinger, thumb, and the second finger of your left hand.
in such a way that they are perpendicular.
Yeah, they are okay. Stretch for finger, thumb, and the central finger of your left hand perpendicular to each other. Okay, then
If the forefinger directs the direction of magnetic field and
if the forefinger indicates the direction of magnetic field,
and the central finger indicates the direction of current,
and central finger indicates the direction of current,
then the thumb will indicate the
then the thumb will indicate
direction of force of current.
and direction of force on the conductor or direction of motion of the conductor. So the answer is the
One.
option 1, direction of force on the conductor. Next question. A TV has a power rating. Power of a TV is 800 watts, and its voltage, record voltage is also given. Record voltage is 240 volt. Okay, that means this TV will work normally for an voltage of 240 volt, and then the power will be 800 watt. You have to find the fuse rating. Fuse rating means why? How did you get it? 3 ampere. How did you get 3? If you calculated this current, no? Safe current you can find. What is the formula? I is equal to. So here we are using this formula. Either of this P is equal to VI, or your knowledge is P is equal to I squared R. Then what? P is equal to V squared by R. Okay, among this we can take this one. Okay, and from that I can find the safe current. What is the power? 800 watts. Okay, 800 divided by 240. Then what will be that number? 3.3 ampere. Dividing will get a 3.3.
3.3.
Yes.
Okay, 3.3 ampere. Then the question is what should be the fuse rating? The options are 1 ampere. 1 ampere we cannot select.
Yes, sir. I got
3 ampere we can select. No, why?
Because it is less than.
It is less than this required current. No, don't round it off. Okay, we need this 3.3 ampere current must flow through the TV, so it must be more than that. And suitable one here is 5 ampere. An alloy of lead and tin is used for the use as a fuse wire. Give a reason why. This alloy of lead and tin has a low melting point and high resistivity. Actually, the required characteristics of a fuse wire is low melting point and high resistivity. Okay,
Yes.
both are satisfied in this case. In the case of what? In the case of alloy of lead and tin. So we are using that one. Okay. Next one. There are 3 wires in the main circuit of household wiring. Name the 2 wires having the same potential.
Neutral and earth.
Okay, neutral wire and earth wire. Neutral wire. What is the potential of neutral wire?
0.
0 volt. And what is the potential of what is that? Earth wire?
0.
0 volt. So both are having same potential. Okay. Next question. A current carrying conductor kept in a magnetic field experience force. What force we are talking about? Lorentz force. Okay. Okay. A current carrying conductor kept in a magnetic field will experience force, and this force depends on some factors. What are the factors?
Current flowing in the wire.
What are the factors?
Strength of the magnetic field.
Okay, first one, strength of the magnetic field.
Current flowing in the wire.
Current flowing through the wire. Okay, intensity of current. Okay. Then
Length of the wire.
length of the wire within the magnetic
Magnetic
field.
field.
If you remember, this is the formula. No. The force experienced by a current carrying conductor kept in a magnetic field depends on the strength of a magnetic field, Then what?
Current flowing in the conductor
intensity of current or size of current,
and length of the wire.
and what is that?
Length of the wire.
Length of conductor. Length of conductor within the magnetic field. Length of the conductor within the magnetic field. Okay. Next question. What must be the angle between magnetic field and conductor in order to obtain maximum force?
90 degree.
That must be 90 degree. In fact, that formula is BIL sin this. Okay, B F is equal to BIL. Beta represents angle between magnetic field and the conductor. That is 90 degree. This value will be maximum. Okay. Earlier we said F is equal to BIL. Considering that angle is 90 degree. Field is like this. Okay. Next one. Next question. What is that? Name the part of an electrical appliance which is to be earthed.
Metal case.
Metallic case of the appliance. Metallic case. Metal case. Okay. The earthing of an appliance is useful only if the fuse is in the live wire. Give reason. The appliance. Okay. So component inside the appliance. Okay. This wire I am calling it. This is live wire and this one is a neutral wire. And here there will be what? There will be switch will be there. And we will have fuse is here also. This is the way we made this live wire and the neutral wire. And this case will be earth. This case will be earth. Okay. This is earth. This is earth wire. What the question says? Earthing of an appliance is useful only if the fuse is in the live wire. If fuse is in the live wire, what is the advantage? If when I switch it on, current flows. Okay. If any leakage is there, imagine, suppose this live wire come in contact with this metal case, then what will happen? This current will get an easy path, no? Instead of going through this resistance, this current is getting one easy path. Because metal is a good conductor, so current will flow like this, okay? The resistance will be less. Resistance less means what? More current will flow. If more current flows, what will happen? This fuse will blows off. Okay. This will be heated and it melts and the circuit breaks. Okay. And if somebody touches the circuit, we don't get electric shock. He will be saved. Let us connect to this one in the. Suppose I am connecting the neutral wire. Okay. Fuse is here. Okay. Circuit is open. No issue. Circuit is, switch is on. Then what happens? Current flows. Okay. Here, suppose what did I say? Due to some defect, this live wire comes in contact with the metal case. So what did I say? This way, if you imagine current flows like this, it will go like this, isn't it? Will the fuse melt? You do not listen to me. High current will not flow through this resistance. So here easy path is there, no? So current will flow through this metal case. Will the fuse melt?
No.
Why?
Because more current is not there.
High current is not flowing through. High current is not flowing through the fuse now.
Yes, sir.
High current is getting another path. It will go like this, no?
Yes.
Fuse will not melt. This appliance will not be disconnected from higher potential, and the person who may touch this may get what? May get electric shock. Okay. And even if you argue, okay, some excess current flows through this, even if you argue this fuse blows, even if you argue that the fuse blows, then also one problem is there, what? Our appliance is connected to high potential. Appliance is still live. Okay. So fuse must be always connected in a
Live
wire. Okay. Next question. Question 3. Two long parallel wires W1 and W2 carry the same current I in the same direction. What is the net magnetic field at the point P midway between the wires? Give reason. What's your answer? One wire is there, another wire is here, and here current flows in this direction I. Here also current flows in this direction. Exactly in the middle, in midway between these two wires, their magnetic field will be
Zero.
How?
That related to direction.
Here, how will you find the magnetic field direction here? Which rule? Which rule? Right hand thumb rule. Using right hand thumb rule, what will be the direction of magnetic field if you consider this first wire W1? It is from here. From here you will be clockwise. This you will see. This is that direction, no? Current flows in that direction. Okay. So thumb must be in that direction. So it will be like this. Inward. Okay. This is towards the board. We're getting that.
Yes.
And in this case,
Towards us.
Okay. From here, this will, if you hold it like this, you will come on outwards. Okay. Which will be stronger magnetic field? Magnetic field due to this first wire or magnetic field due to second wire? At this point, which will be stronger? Both will be same.
Yes.
Because magnetic field depends on current flowing. Same current is flowing, no? So the magnitude of magnetic field is the same, but they are in a opposite direction. So they will get cancelled, and here the resultant magnetic field will be 0. So that is the first answer. Second one, if the current in the wire W2 is reversed, okay, current in the wire, so magnetic field, resultant magnetic field will change now. It is not 0 right now. You have to just state the direction of magnetic field. Okay, so magnetic field, resultant magnetic field will not be 0. Well, what will be the direction? Question is whether the magnetic field is inwards or outwards at this point.
Inwards.
Inwards, away from it. In other words, away from the observer. It is towards the board, but away from the observer. Next one. An electromagnet is made by passing current in a coil wound around a piece of soft iron. Diagram alongside shows a soft iron piece AB. Copy the diagram and show how you will wind a coil around AB so that it can act as an electromagnet having north pole at the end A. So copy the diagram. When you copy the diagram, you have to copy the diagram exactly. This is A, this is B. Don't copy the diagram this way.
I did that.
Don't do that way. You don't know how to copy. Exactly, you will copy. Okay. Then they need what here north pole. So what should be the direction of current there? How will you arrange that?
Anti-clockwise.
Anti-clockwise, no?
Yes, this side.
So how will you wind it? So shall I wind it like this? Okay, I am showing the winding like this. Imagine. Okay, like this. Here I have to connect what? I have to connect battery. Before connecting battery, I am thinking like this. I need the north polarity here. How is that possible?
Current should flow from
This side the positive
Side.
terminal will be there and this side negative.
Very simply, just take your right hand and you need a north pole here, no? So that direction you can keep your thumb, and then these fingers, no? That will show the direction of a required current. So if it is like this, see, my fingers are in that direction. So here, direction of current must be like this. Here.
Yes.
Okay. So if you imagine you have some here, like this, and here this way. That means this end must be positive terminal. But we always need one key.
Yes, sir.
Key is required. And if you want to, it is an electromagnet now. If you want to vary the magnetic strength, we need one
Resistance.
rheostat also. We need the rheostat. Name the device that you have drawn in your diagram to change the strength of the electromagnet formed.
Rheostat.
Rheostat, what is rheostat? That's a variable resistance only. Rheostat is a variable resistance. Rheostat is used for what? In a circuit we use rheostat. For what purpose? To vary the current. That's all. If I vary the current, quite naturally, strength of electromagnet will vary. Then next question, that is very easy. Question is like this: MCB and main switch are two safety devices used in household circuits. What does MCB stand for?
Miniature circuit breaker.
Miniature circuit breaker. Write one advantage of MCB over an electric fuse.
It has quick response.
Okay, MCB has a
Quick.
quick response. How many seconds?
Milliseconds.
How many milliseconds?
25.
Okay, it will work within a 25 milliseconds. Approximately it will take 25 milliseconds. That is mentioned in your book. Okay. Next, what is the relative position of main switch? The relative position of main switch in household circuit. Where is that main switch? Hmm?
Before the
The before distribution box. And
Before distribution box.
10 kilowatt meter.
So, okay, between kilowatt hour meter and the
Distribution box.
Okay, that's a funny question. Let it be. And last one, what is the advantage of using main switch? What is the advantage?
Connections of live wire and neutral wire from the main switch.
Once again,
It breaks the connection of live wire and neutral wire simultaneously.
simultaneously, this main switch will break the
Connection between the live wire and neutral wire.
Connection of live wire
connection of live wire
and neutral wire
and neutral wire from the.
main supply.
Okay, will you read it from the book?
The main switch that breaks the connection of the live as well as the neutral wire simultaneously from the main supply.
Okay.